Okay guys, this is the Unit 2A test review. I'm going to go over kind of the main types and the main ideas. We'll probably do this in 2 videos, and I'm probably going to do all of the odd problems, and then I'll leave the even problems for you to try on your own. Alright, so starting with number 1, this is just an add like terms, and then it wants us to put it in standard form, give the leading coefficient, the degree by name, and the number of terms by name. So because I see this minus sign here, we're going to go ahead and distribute that negative, and we've got 3x squared plus x minus 5 plus 2x minus 6. Now we want to add those like terms, so I've got 3x squared plus 3x minus 11. Alright, now that I've combined the like terms, it is in standard form. Now that it's in standard form, we want to go ahead and put down the leading coefficient. The leading coefficient is always the number in front of the highest exponent, not the variable, just the number. So in this case, just 3. And then we need the name by degree. And so that's going to be looking at the highest exponent, and if it's a 1, it's a linear term. If it's a 2, it's a quadratic. If it's 3, it's cubic, that sort of thing. So because our highest exponent is a 2, our degree is 2, and therefore this is a quadratic. When we name by term, this is counting how many terms there are in the polynomial. So if there's 2, we call it a binomial. If there's 3, like we see here, 1, 2, 3, that's called a trinomial. If it's 4 terms or more, we call that a polynomial. Alright, on number 3 here, we have 3 terms that we are needing to FOIL, and you can only ever distribute 2 parentheses at a time. So we're going to go ahead and FOIL the first 2, and what I notice here is that they are the exact same inside the parentheses except for the sign, which means x minus 4 and x plus 4 are factors of a difference of squares. So those middle terms are going to cancel out in this case. It doesn't always happen like that. You can't just assume, but because these are identical with opposite signs, I know it's going to be a difference of squares when I FOIL it. So I'm going to get x squared minus 16, and then we're going to drop down that x minus 4. And now we're going to FOIL just like we did before. So I'm going to get x to the 3rd power minus 4x squared minus 16x, and then 16 times 4. It's too early to do that off the top of my head. So plus 64. Alright, that already is in standard form, going from highest exponent to lowest exponent. There are no terms for me to actually combine, so that's standard form. The leading coefficient is the number in front of the highest degree. So x to the 3rd is the highest term. The number in front of it is really an imaginary 1. And the name by degree has to do with that highest exponent. So since my highest exponent is a 3, we call that a cubic function. Because we are naming this also by term, I got to count how many terms there are. And since there are 4 terms, 1, 2, 3, 4, that makes this a polynomial. Alright, for number 5, we need to not only add like terms, but we also want to simplify based on the eye chart. Now the eye chart is I1, I1, with the negatives in the middle, and they really represent I squared, I cubed, and I to the 4th power. If you want to think about these as a remainder, it's when you divide the exponent by 4. If I get a remainder of 0.25, my answer is going to just be I to the 1st, or I. If my remainder is 0.5, it's I squared, and I squared equals negative 1. If my remainder is 0.75, it's I cubed, and I cubed equals negative I. And if I get a whole number, so no remainder at all, it's really I to the 4th power, which is really just equivalent to 1. So there's more than one way you could go about this. I'm going to go ahead and simplify by distributing this negative first to get rid of the parentheses. So I've got 5 plus I cubed minus 3 plus I cubed. Alright, and now I'm going to go ahead and add like terms. So I've got 5 minus 3, which is 2, and I have 1i cubed plus 1i cubed, which is 2i cubed. Excuse me. All right, I cubed really equals negative I. So I'm going to replace that with negative I. So my final answer, just simplifying, is 2 minus 2i. All right, on number 7, it wants us to use Pascal's triangle. So Pascal's triangles is that 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, and 1, 5, 10, 10, 5, 1. And we can build that just by adding the two terms on the top. So 1 plus 1 is 2. 1 plus 2 is 3. 2 plus 1 is 3, and so on and so forth. All right, so for Pascal's triangle, when I have two terms here, I'm going to set mine up a little differently into columns just because I know I'm going to have a lot of terms here, and it will help me simplify. So because my exponent is a 3, I know in Pascal's triangle I want to use 1, 3, 3, 1. So I'm going to write that at the top. 1, 3, 3, 1. Underneath, I'm going to start with the first term, so 2x. And that 2x gets raised to the third power. So I've got 2x to the third. Now keep in mind that 2x needs to be in a parentheses. And then I'm going to go down the row. So 2x squared, 2x to the first, and then technically I have no 2x left because it's 2x to the 0 power, and anything to the 0 power is always 1. All right, then I'm going to look at the negative 4y, and that negative is important, so don't forget the sign. So that negative 4y, since it's the term on the right, I'm going to start over here on the right, and because that exponent is a 3, we're raising it to the third power. And then we're going to move right to left. So I've got negative 4y squared, negative 4y to the first, and then there is no negative 4y last because it's technically negative 4y to the 0, and anything to the 0 power is 1. And now when I'm trying to combine these like terms, I'm just going to multiply down, multiply down, multiply down, and write down what I get. But because I have parentheses, I know that this is going to be a lot of distributive property. And remember, a power to a power, you always multiply. If it's a coefficient to that power, you need to go ahead and evaluate that number. All right, so I'm going to start off left to right. So 2 to the third is 8. X to the third is just x to the third. So my first answer right there is just going to be 8x to the third. All right, if I look here, I've got 2 squared, which is 4. 4 times 3 is 12. 12 times negative 4 is negative 48. So negative 48, x squared, y. So it's x to the second power, y to the first power. All right, now I'm going to go to the second row here. So I've got negative 4 squared, which is 16. 16 times 2 is 32, and 32 times 3 is 96. So we just did negative 4 squared times 2 times 3. All right, so we've got 96. I have one x but two y's, so x y squared. And then lastly, negative 4 to the third power and y to the third power. So negative 4 to the third power is negative 64. And then y to the third. And that's going to be my final answer. Okay. All right, on number 9, the only difference is that we are using Pascal's triangle, but now we have it with I. So same process. I'm going to start off with a 4. So I've got 1, 4, 6, 4, 1, following Pascal's triangle. And then I'm going to start off with a 5, and we're going to raise that to the exponent and go down in decreasing order. And then I'm going to take that 3i and also raise that to the fourth, but this time going right to left because it's the term on the right. So 3i to the fourth, 3i to the third, 3i squared, 3i to the first, and then nothing. All right, keep in mind, guys, whenever you have that exponent, you have to distribute to both the coefficient and the variable separately. All right, so we're going to start off left to right. So I've got 5 to the fourth times 1. 5 to the fourth is 625. Times 1 is still just 625. Then I've got 5 to the third, which is 125. But I need to multiply that by 4 and 3. So I'm going to multiply 125 by 4 and 3. And we get 1,500. I, because we had one I. Alright, then I've got 5 squared, which is 25, times 6 times 3 squared, which is 9. So I'm going to do 6 times 25 times 9, and we get 1,350 I squared. Alright, then I've got 5 to the first, so just 5. 5 times 4, which is 20. 3 cubed is 27, so I'm going to do 20 times 27, and we get 540 I to the third power. And then I've got 3 to the fourth, and 3 to the fourth is 81. So lastly, I've got 81 I to the fourth power. So now what I need to do is go ahead and simplify the i's just like we did in number 5. So I squared is -1, I cubed is -I, and I to the fourth is just 1 according to the I chart. And now I'm just going to go ahead and add like terms. So I've got 625 is a whole number or a real number, plus -1,350, because that's also a real number. And then I've got plus 81. So those are all my real terms, and I get -100, 644. Now for my imaginary terms, I've got 1,500I plus 540, or sorry, minus 540I, because of that -I right there. So 1,500 minus 540 is 960. So I've got 960I. Now the good news is with the I, you can always check it in the calculator. So if I go into my calculator, here's my screen, that's a little easier to see, and I type in the actual question, 5 plus 3I to the fourth power, and I hit enter, I do get -644 plus 960I, which is what we got by hand. Just keep in mind, you can use that calculator to check, but you do need to show your work to get credit. Alright, on number 11, it's asking me to find the coefficient for the term that is xy squared. And keep in mind, the coefficient is just the number in front. So I don't actually need to do the entire binomial expansion. Really what I need to do here is just do Pascal's triangle for that particular term. So I know it's 1,331, and I know it's x cubed, x squared, x, and then I know I've got 2y cubed, 2y squared, 2y. And if I look in here, I want the one that's got x and a y squared. So I'm really only interested in this term right here. So that's the only one I really need to spend my time simplifying. So I'm going to do 2 squared, which is 4. 4 times 3 is 12. So my final answer there for the coefficient is just 12. I don't need to go any further than that. Alright, on 13, it's asking me for the third term. So I'm going to do a similar thing, and I'm only going to actually work out the third term. So we know we've got 1, 4, 6, 4, 1. And I know I've got 2x to the fourth, 2x to the third, 2x squared. Now because I'm only looking for the third term, I'm not going to continue on with the 2x. But you could. For -3 to the fourth, I know that starts over here, -3 to the fourth, -3 to the third, and -3 squared. And again, because I'm looking for that third term, I'm going to stop once I've got all my terms there. And then I got to distribute that to both the coefficient and the variable. So 2 squared is 4, 4 times 6 is 24, and then -3 squared is 9. So if I do 24 times 9, I get 216. And then I get my x squared, and there is no y or I or anything else, so 216x squared is my third term. Alright guys, these are the odd problems on the front side of the test review sheet. I'm going to start on the back side in the next video.